stream, guys. Couple of Java Live here. We need to talk about something. And that is solar system, guys. All right, we're getting deep. We're getting into it today, tonight. It's nighttime, but what does it matter? I mean, we're all spinning around the sun. So, without further ado, let's get into the formation and evolution of the solar system, as read by me, Capo Java. Now, our solar system began 4.6 billion years ago with a gravitational collapse of a small part of a giant molecular cloud, okay, or a stellar nursery. Now, most of the collapsing mass collected in the center, forming the sun, while the rest flattened into a protoplanetary disk out of which the planets, moons, asteroids, and other small solar system bodies formed. This model, known as the nebular hypothesis, was first developed in the 18th century by Emanuel Swedenborg, Immanuel Kant, and Pierre Simon Laplace. You'll notice that guy from Laplace theorem, Courtney and Zach. That's the Laplace guy. He had to bring up this too. He's doing that now. Its subsequent development has interwoven a variety of scientific principles, including astronomy, since the space age in the 50s and discovery of exoplanets, which, okay, fine. I mean, that's beyond the solar system, guys. What's that even doing here? All right, scrolling down. Okay, this is a protoplanetary disk. So this is like the womb of a solar system, guys, and we'll get more to that in a second. But this is where it got deep, and I decided I needed to talk about this. Okay. I didn't know this. Solar system evolved. Many moons formed. Earth's moon was due to a giant collision, sometimes called the Big Splash. I mean, whenever someone says they're taking a big splash, they're talking about the moon crashing into the Earth, which they're now. Yeah, okay, I'm not getting into that. I was going to talk about Artemis, but another day. They didn't take my application. I was one of the 12,000 for the 2020 March 2020 class that just graduated today. But whatever. Guess they didn't like my astronaut resume. They didn't want me up there fixing dishwashers for them, so stuck down here with you guys. Great. But anyway, it doesn't matter because I'm getting to that. In 5 billion years, the sun will cool and expand its diameter, becoming a red giant. Now, the picture of a red giant's terrible, but just imagine a big red sun swallowing the closest planets. I guess I'll get to that later. And then becoming a white dwarf. Okay. Some will be destroyed and others possibly ejected into interstellar space. So our solar system, the sun's going to eat some of them and then retreat back into a white dwarf. So Earth is going to come back to a white dwarf, or we're going to be shot into interstellar space with Matthew McConaughey. So one of those is going to happen over the course of tens of billions of years. It is likely that the sun will be left with none of the original bodies in orbit. It's just going to be a white dwarf. All of our stories, everything is just going to be a white dwarf, or we're going to be in a rock with Matthew McConaughey in space. The history, we can kind of skip this. I was kind of getting down to the science of it. Laplace and giants, red giants. Stick to math, Laplace. Out of my astronomy. All right. Now this is like, look, this is in Orion, the constellation Orion. They have some new stellar nurseries, probably similar to how we started. And see, there's another solar system forming. You know, if those walls could talk, they are going to have some stories whenever they get existence and all that. So that's coming, guys, to Orion. But I don't know where we'll be at that time. All right, we have a birth environment, formation of the planets. Inner solar system was too warm. I didn't even read this part earlier, guys. I don't know what this says, but I'll read it later. Giant planets formed further out beyond the frost line. And ice has formed the Jovian planets. 10 million years. All right, I'll come back to this. There's this timeline at the bottom. Oh, yeah, planetary migration. Apparently, Uranus, American accent, Uranus and Neptune, the ice giants, they kind of spun around like crazy and had different orbits or something. They're out of place in the solar system, is what this says. It said with the contents of the planets, that where they are now is not where they were formed. So those planets moved somehow. Um, I kind of skimmed this. I don't know why they moved, but I'm leaving the link in the. I'll put the link in the description, guys. All right. Meteor crater in Arizona, big deal. We got one over here in Odessa. We got meteor craters everywhere, guys. All right. Meteors are a part of life. Let's watch the movie Meteor Man. All right. Now, moon rings. Ring nebulas. It's got a lot in here, but this is the part that really got me going here. This chronologically, the formation of the solar system. Now, the age of the universe is a different topic, but supposedly they looked at radiation and said that it's somewhere around 13.6 billion years old or something. I don't remember the exact number from this afternoon when I was reading it, but let's just call it 13 to 14 billion years, give or take, huh? Anyway, so previous generations injecting heavy elements out into the space, pretty much. Billions of years before the solar system. Okay, 4.6 billion years ago, so that's the universe is 14, we're 4.6. We're about 10 billion years in. All right, guys, keep up with the math here. In an Orion Nebula, most live, die in supernova. One supernova possibly triggers the formation. So, 50 million years before our solar disk was formed, some huge star went poof. Okay? The solar nebula, sun begins to form. Formation of the sun, 0 to 100,000 years. And then 100,000 to 50 million years. Now, why are we going different? Sun as a T-Tauri protostar. I didn't mean to click that. Tens the disk. Outer planet formation is lightly complete. 10 million years ago. Planets, 10 million years. Alright, I'm getting lost in this sun business. Terrestrial, the moon formed. Giant impact occurs. Water delivered to Earth. Okay. Water's delivered to Earth. All right. How did someone delivered water to Earth per reference to? Well, that was an important delivery, guys. If that delivery didn't happen, we would not be here, right? Without water. I don't know what this video is, guys, but I'm pushing through it. We finished what we start here. Okay, today, 4.6 billion years. Oh, imagine that, DoorDash. Oh, gosh. I hope we left a big tip because water, if Earth didn't have water, it'd be what? Rock. We didn't even get rocks. Oldest known rocks, 200 million years ago. We got that delivered. We got water. We got rocks. Saturn out into the Kuiper belt. Heavy bombardment. Oldest life on Earth. Earth Urt cloud reaches max 800 million years ago. All right, 4.6 billion years. Sun remains a star. Okay. Oldest 3.8. What is this timeline? 800 times since formation of sun. 800 million years after the sun, we get life. 4.6 billion years after the sun is today. 6 billion years after the sun, so 1.4 billion years in the future, we. Billion years, okay. The sun habitable zone moves outside of Earth, shifting to Mars. Okay, we get too hot. And then Mars is loving it. Okay, so Mars's time is about 1.4 billion years from now. 7 billion years. Okay, so 2.4 billion years in the future. The galaxies start to collide with the Andromeda galaxy. So we're going to collide with another galaxy, guys, in 2.4 billion years. 2.4 billion years from this video, our galaxy is going to collide with another galaxy. All right, slight chance we could be captured before the galaxies fuse completely, but who cares? All right, 5 to 7 billion years in the future, the sun used all of its hydrogen and ending its main sequence of life and starts to burn hydrogen in the shell bin to ascend the red giant branch, growing dramatically by a factor up to 250 in radius and cooler. Okay, so a red giant. They got to get a better picture than that. Mercury, Venus, and possibly Earth are swallowed. All right, 10 to 12 billion years. Earth may or may not be swallowed. Not important. They didn't do the math by a factor of up to 250 in radius to put a chance to know of Earth's uh, resting place. You know what? I'm going to do the math and do a follow up video because I need to know if Earth is going into the sun or if we're going to Interstellar with Matthew McConaughey. Which one do you prefer? Leave it in the comments. I'd like to know. Personally, I feel I'd rather be. I don't know. I could go either way. I kind of like the sun gave us life. It's like our solar system. So then you would go, we'd be in the white dwarf. We'd be like a white dwarf just sitting in space, burning bright. Forever. But, I mean, I don't know how long does a white dwarf last? And then after a white dwarf, I'll look into that. We'll click on that one. But or we go out into space and like the Earth gets sucked in a black hole, or or just floats and maybe goes. It's not gonna end well. I mean, unless it gets really lucky and finds a star and just starts orbiting that star in a habitable zone, then life comes back. Or or we get eaten by our original sun. 1 quadrillion years, sun cools to 5 Kelvin. Gravity detaches planets from orbit. Solar system ceases to exist. Sun passes through helium burning horizontal branch. Losing 30. Okay, so this is the white dwarf. We go red giant to white dwarf. And then helium. So we all have high pitched voices, and that was a terrible joke. Sorry, but yeah, so white dwarf. So what is the life? If we get eaten by the sun, what happens after white dwarf? What is it? Supernova? Get over yourself. There's not going to be a habitable zone on the surface. Size similar to a planet. That's kind of cool. Uninhabitable embers. Doesn't matter. This whole page, this video, it's going to get burned up. All these words, they're going to get burned up eventually. This computer's going to melt. YouTube's going to melt. The data center that's holding all this information is going to melt. I'm just putting all my chips on Jesus, guys. So that's all we got. Everything else is going to melt to that. White dwarf. Mass comparable. If they only knew what's going to happen to the sun. White dwarf comes Sirius B. Okay. You know what? We're getting math here. Distance. Okay. I don't want to dox myself. Distance to Earth 93 million miles. Diameter 93 mil. Sun diameter 865. All right. Now I gotta figure out 93 million miles to the sun. 865 to the 250th power. Is that what it said? 250 times. So if you have a 1 inch circle, and then that is to the. What power? 250 times the 2 pi r is not it. You need the r. It's 250 times. What's r times that? Wait, that's the diameter. Okay. Sun radius It's after work, okay? I'm allowed to Google this. All right, so that times 250 sub radius, that times 250 equals, what is that? 108. Okay. 108 million is the max. So red giant, 108 million to what, 93 million? Okay, so if it's 250 times larger, Earth is getting swallowed. So we're in the white dwarf scenario here. So set up to 250. Either way, I guess we just don't know how big is the red giant going to be for the sun. How big red giant for sun? What do you mean possibly Earth? It will reach 300 million kilometers in diameter. Between 62 and 621 million miles. If that's the range, then it's very likely that we're going to be Operation White Dwarf, guys. So, sorry, Matthew McConaughey, we are not. We are not going. Matthew McConaughey. We are not going interstellar. Interstellar. And we are going Operation White Dwarf Sun. And that is our future, guys. We're going White Dwarf, Operation White Dwarf, whatever. I think it's cool anyway. We're all going to be burning together in the end. In a bit, we're going to get Venus. We're going to get Mercury. And we're all just going to sit there and then we're going to watch people living on Mars. There's going to be habitable on Mars, so maybe we'll be around then. Or on Mars by then. Um, but yeah. So there you have it, guys. Just had to figure this stuff out and see where this is all going here. Um, Something to look forward to. All right. Thanks for watching. And see you in the stars.